Hi everyone. Thank you for joining this workshop today. My name is Nami and I'm a full stack Ethereum developer at OpenZeppelin. And today I'll be introducing you to our newest feature, Timelocks, using OpenZeppelin Defender. So I'll talk to you through how you could use it to provide users, protect your users and provide your users with more guarantees. So I'll also show you how to set up and deploy a Timelock. So first, let me quickly talk about what is scheduled for this workshop. So I'll briefly talk about OpenZeppelin as a company and Defender as a platform. I will then go through some scenarios where Timelocks were used and even saved some projects. Then I'll do a more hands-on session. So this will include creating an ERC20 token and importing this into Defender. Creating and deploying a Timelock, and then executing a proposal through that Timelock. And then I'll also discuss the risks of a Timelock, and we'll have a short session in the end for any more questions. So for those who are not aware, OpenZeppelin is a cybersecurity company that focuses on blockchain technology. So our mission is to protect the open economy. We work with projects of various sizes, and we perform security audits as well as manage our own products for decentralized systems. So OpenZeppelin is all about bringing security to the DeFi space. We specialize in three things. So we provide audit services that ensure contracts and protocols are secure. We offer open source tools. So the main one is the contracts library, which acts as a building block for decentralized applications. But we also have a contracts wizard to generate different types of contracts, for example, an ERC20 contract, which I will also be showing you in this workshop. And we have an upgrade plugin for Truffle and Hardhat. We also have a platform called Defender that manages these dApps from an operational and security perspective. And essentially, we want to make it easier for anyone to ship dApps faster and more securely. So some of you might know Defender has several components. If you have not used these before, I definitely recommend checking it out. But we essentially cover 5 aspects. So you can use admin to manage your smart contracts. You can use Relay to store your private keys and provide you with a web-based API for transactions. You can use Autotask to automate calls to your smart contracts. You can use Sentinel to monitor smart contracts and send you notifications and alerts. And you can use Advisor to implement any security best practices. However, for this workshop, we will mainly focus on admin, which acts as an interface for contract administration. So we will start with creating a Multisig wallet to replicate a real-life setup. Then we will deploy a simple token contract using the OpenZeppelin contract wizard and import this into Defender. And we will then follow that up by creating and deploying a Timelock and setting up the appropriate roles. And the final part, we will submit a proposal through that Timelock, for example, to mint new tokens, which then needs to be approved. So to achieve all of this, we will be using just 4 functionalities within the admin component. So you might still be wondering why a project actually needs a Timelock. So the problem really boils down to trust. A lot of people have lost money from rug pulls and scams, and most of the times project owners or developers steal tokens that were supposed to be used for like staking, liquidity mining, or yield farming. For example, in 2017, we've seen a record high of ICO scams where developers simply ran away with investors' money or dumped a big share of tokens, affecting the price. So the problem is having to trust project owners and developers. So we saw this last year. The creator of SushiSwap sold his share of tokens, which caused a 99% dump of the sushi token price. And you can imagine this harmed the community. So to restore the confidence of its investors, the community voted to lock 66% of the newly minted liquidity provider tokens, or LP tokens, for 6 months. And this was done through Timelocks. So this gave the project some time to reestablish itself as one of the leading decentralized exchanges. Another scenario is that of PancakeSwap. So they made use of a Timelock slightly differently. The developer set up a time lock contract, which would broadcast any protocol changes for 6 hours before going live. So this would allow the community some time to react to the changes and then prepare accordingly. It would also allow traders and liquidity providers to jump into new pools, as they can just monitor the time lock contract for any changes and then be ready as soon as that change goes live. So we're seeing more and more rug pulls and hacks and scams in this space. So projects need a mechanism to reassure their community that founders and developers won't just scam them. And one of these methods is a time lock. So we already have multisigs, which help manage the risk by eliminating that single point of failure. So funds are protected by multiple keys, which makes it harder for malicious users to spend these funds without approval from every other owner of that multisig. Also, if a key is compromised or lost, depending on the signature threshold, the funds are not necessarily lost. So time locks add additional security. In case a private key is compromised, there is still a window of time to react before a malicious proposal is executed. So from the previous scenarios, a time lock can stop a rogue development team from unilaterally executing an action, which is then detrimental for the community. So it allows investors to exit the protocol in time if necessary. So essentially, project admins are giving up control to provide more guarantees to the stakeholders. So it reduces the level of trust required from the community and thus decreasing the risk for the community. So what really is a time lock? A time lock is a smart contract that delays function calls of another smart contract until a predetermined amount of time has passed. So most of the times, this is the ability to transfer a token out of the contract. So it makes funds inaccessible until a certain date or time. So it's very similar to a vesting schedule. Generally, time locks are used by project owners to demonstrate that their commitment to the project. And the time lock could also be seen as one of the few indicators that a project is legitimate. So our time lock controller contract, which you can now deploy from Defender, consists of 3 roles with different permissions. So setting this up properly is crucial for the time lock to be as effective as possible. The proposers are in charge for scheduling and canceling operations. Now, this is a critical role, so that should be given to governing entities. This could be an externally owned asset, a multisig, or a DAO. The executors are in charge of executing the operations scheduled by the proposers once the time lock expires. So logically, multisigs or DAOs that are proposers should also be executors in order to guarantee that these operations will eventually be executed. However, there's no problem adding more executors because they will only be able to execute proposals that have already been pre-approved anyway. The admins are in charge for managing the proposers and executors. So ideally, you'd want the time lock to be self-governed. So the role should only be given to the time lock itself. But upon deployment, both the time lock and the deployer will have this role. So after configuring and testing, the deployer should then renounce this role so that all further operations have to go through the time lock process itself. There's a couple of things to consider. A live time lock contract without at least one proposer and one executor is locked. So you have to make sure that these roles are filled with reliable entities before the deployer renounces its admin rights. And also proposers have say on all operations. So they could cancel operations they disagree with, including operations to remove them from the proposers. So make sure that this role is only given to reliable people. So just to give you a visual, in this case, we have a multisig owner or an externally owned asset owner who directly calls a critical function on the target contract. So this is then executed, and there's nothing anyone can do if this action turns out to be bad for the community. So for example, if this was an ERC20 token contract, the owner could mint 1 billion tokens, and that reduces the value of the circulating supply. In this case, we ideally have multisig owners. that have given up ownership of the target contract to the Timelock. So the Timelock is, in this case, the owner or admin of the target contract. The multisig then acts as a proposer and sends a proposition to the Timelock, for example, to mint 1 billion tokens. The Timelock then delays this action by, say, 48 hours, which gives the community the time to react, and it essentially provides them with an escape hatch. If they believe minting 1 billion tokens is not good for the project, they have time to sell their tokens before it devalues. Then once the 48 hours have passed, an executor can then realize this action to mint. So if it's still a bit fuzzy, the demo should help clear things out. So I will just start with deploying a ERC20 contract. So I'm using the wizard that that Fran actually developed a couple months ago. And it's quite a handy little tool if you want to deploy a contract really quickly. So I'm going to be using the ERC20 setting. I'll just name it workshop token with ticker WST. I won't pre-mint anything for now, but I will check the mintable feature, and I'll make sure that access control is ownable. So as you can see, the wizard automatically imports the necessary contracts. It renamed the token, and it created this mint function with the only owner modifier. So that means only the owner of this contract will be able to call this mint function. I'll then open this in Remix. And make sure I can compile it. There we go. And then simply deploy it. I have created 3 accounts. So I've got workshop 1. I'm not sure if you can see this. Workshop 1, workshop 2, and random. I'll be using workshop 1 as my main account in this case. So I will deploy the workshop token. Just connect to MetaMask and deploy. Then I'll be asked to sign this to confirm this transaction. There we go. Just confirm that this has gone through. So we've got our contract address. This is our ERC20 token. Just going to copy this. What I'm going to do is I'm going to import this into Defender. Right, so on the left-hand side, you can see we've got all our components I was talking about earlier. So we've got advisor, sentinel, auto task, relay, and admin. For this workshop, I'll just be using admin. So to import a contract, we'll just press the button on the right top corner, import contract. And I'll call this workshop token. We've deployed it on the Rinkeby network. So I will make sure to select the Rinkeby network, set up this address. Now, since this contract is not verified on Etherscan, Defender won't be able to fetch the ABI automatically. So we will have to copy this from Remix. Just go back to the compiler setting and then select the workshop token. We should be able to copy the ABI just here. And then paste it in. And then just add. There we go. You can also confirm that we are in fact the owner of this contract. There we go. So workshop token 1. I should mention I have added these accounts before. So the main workshop 1 account, I also have a workshop 2 account. So this is how you'd see them as. Cool. So now we have our workshop token. I will just add a multisig as well. So you do that by, in the same admin menu, add contract, and then create a Gnosis save. And we'll call this workshop multisig. We will also deploy this on the Rinkeby network. And as for the owners, I will add both my workshop 1 and workshop 2 accounts. There we go. And I'll put the threshold on 2. That means both workshop 1 and workshop 2 will have to approve any transaction that comes through this multisig. So we'll create this and then confirm the transaction. So just to go back to the flow, right now we have created our target contract, which is the token contract. We are in the process of creating our multisig, of which there are 2 owners, so workshop 1 and workshop 2. And then the next step would be to create our Timelock contract. So this is confirmed. We can just double check that everything is fine. So we've got our workshop multisig, we've got our 2 owners. If you just hover the get owners value here, you can see that there's 2 addresses in there, and the threshold is 2. Next, we will add our Timelock. So you do that exactly the same way. You go to admin, add contract, and then create Timelock. I'll just copy this because I will need this. So we'll call this workshop Timelock. We'll also deploy it on Rinkeby. And for the proposers, I'm going to add the multisig. Reason being, obviously, we want this multisig to be the proposer on this Timelock. So we as owners are the owner of the multisig, and then the multisig will be a proposer on the the multisig will be a proposer on the Timelock. So that's what we're setting up right now. And our multisig will basically be able to submit any proposals. And then we have executors. We can choose either we can add individual executors. So we can set up individual addresses to, and only those addresses will be able to execute any proposals on the Timelock, or we can allow anyone to execute a proposal. For the sake of the workshop, I'll just allow anyone. The admins, as I said before, the deployer will be an admin of the Timelock and the Timelock itself. So if I deploy with my workshop 1 account, then I will automatically be an admin of this Timelock. And then for the minimum delay, I will just set this at 30 seconds. This is basically the minimum delay for the Timelock. So anytime you submit a new proposal, you'll have to set up a delay. Ideally, you want this to be slightly higher than 30 seconds. But just for this workshop, I'll put at 30 seconds so we don't have to wait too long. So I will create this Timelock. I can monitor the status here as well. There we go, that's created. So if we go to the Timelock admin action, we just want to make sure that everything, all the roles are verified. So we've got 3 roles here: the executor role, the proposer role, and the Timelock admin role. And we can see our minimum delay at 30 seconds. This will always be displayed in seconds, by the way. So let's start with the proposer role. We can just verify that who has the proposer role. So for the Timelock, we've given the proposer role to a multisig. So we'll go to query other functions and just verify this. So I'll copy the proposer role here and make sure that our workshop multisig is the account with the proposer role, which yields true. As for the Timelock admin, we've set up, so the deployer will have it, as I mentioned before. So workshop 1, this should have the admin role, and the Timelock itself should also have the admin role. So we can verify that as well. And this yields true. So for the executor role, this is a bit of a weird one because we've set up everyone to be an executor. So the way you can verify this is by comparing it to a 0 address. So if you go to the documentation and then contracts, governance, you'll see documentation about the Timelock controller here. If you just do a Control F on address 0, you'll see that granting a role to address 0 is the equivalent to enabling this role for everyone. So if we compare this role with a 0 address, which is just 0x and then 40 zeros, we're able to see that this also yields true. So I'm quite happy with this setup. We've got at least one executor, we've got a proposer, the only problem is that we have two admins, right? We have the Timelock itself and me as a deployer. So since I'm happy with this setup, I should now renounce my admin rights on this Timelock contract. So I'll do that by just calling the renounce role function, copying it over the Timelock admin role, and then selecting which account. I can do this from an externally owned asset because I'm still the admin, and admins can manage proposers and executors. So renounce ownership. So renounce admin rights. I'll create this admin action. And I'll just approve and execute and confirm this transaction. There we go. This is now executing. You can also verify any proposals coming in. So if you go to the workshop Timelock, I will have a section on proposals. In this case, we've just added one, when it was, what type of action, and whether or not it was executed. So in this case, it's now executed. So we will be able to confirm this now. If I do the exact same thing, so check if
I think we lost Nami there.
Yeah, it seems so. Oh, there he is.
hello. I'm not sure
Hey,
where I
Nami.
lost you guys.
Yeah, we lost you there for a minute or so.
For a minute. What's the last thing? Should I go back to the proposal stuff over here?
Yeah, that was about it. You had
All right,
come
cool.
back to the proposal.
Yeah, all right, sorry about that. So I'll just go back here. So we just verified that I've renounced my admin rights. We can see when this was and whether or not it was executed. So now I'll be able to verify this action by just copying this Timelock admin role again and doing the exact same thing. So we can go as role and make sure that workshop 1 doesn't have any admin rights, which now yields false. So that's perfect. So now this Timelock contract is completely self-governed. So just to recap, we've got our token, we've got our Timelock, and we've got our Multisig. The Multisig is a proposer on the Timelock. The only thing right now is that the workshop token, if we just compare the workflow here, the token contract, I still own that token contract. I'm still an owner. So workshop 1 is still an owner of this target contract. So ideally, we want this to be the Timelock contract itself, right? So the way we would do that is by renouncing or transferring the ownership. Actually, let me just show you another thing. So right now, as an owner, I will be able to mint. I'll be able to mint as many tokens as I want. So let me start with just minting 1,000 tokens, and it should work perfectly fine. We can double check here. The total supply is 0. I'll just approve and execute this and confirm the transaction. Then we can go back and verify that this proposal is coming through. Right now, the total supply is at 0. So once this is executed, you can see the total supply is now changed to 1,000, right? So right now I could act as someone malicious in this case and make bad decisions for the community. So what we want to do is transfer the ownership of the token contract to the actual Timelock. I can do this as an EOA because I am the owner. Right now, approve and execute. So what we've done now is transfer the ownership of this ERC20 token contract to the Timelock. We are, as a multisig, proposers of this Timelock, and we have allowed anyone to be an executor on this Timelock. So this is the exact diagram that is now complete. So we can just double check that I'm no longer the owner of this contract. So now if I try and mint some tokens, I won't be able to do this because I'm not the owner. And from the contract, I can just recap that this mint function can only be called by the owner of the contract. So right now, what I can do is, since the Timelock is now the owner, I can change the execution strategy and make sure that the Timelock is calling this mint function on the token contract, right? So I've selected Timelock, selected which Timelock, and it's automatically fetched the minimum delay that we've set, which was 30 seconds. I'll just keep it 30 seconds, but we can increase this as much as we want. And I'll try and attempt to mint this again. Now, again, this should fail because, as you remember, my externally owned asset or workshop one account is not an actual proposer on this Timelock, right? So we will have to change it to the multisig, which we have assigned as a proposer on that Timelock, and then try and mint those tokens again, and that should work. Right, as you remember, it requires at least 2 approvals. So we have 2 signatories on this multisig, workshop 1 and workshop 2. So currently I'm logged in as workshop 1. So I'll just approve this action and then sign it. Keep in mind, I can still reject this. I'll then log in as workshop 2. Which is a second signatory, and then I'll just approve and schedule this as well. There we go. So this is all approved and it's currently scheduling. This state means the transaction is currently still being mined. Now it has changed to scheduled, which means the delay kicks in from now. So we've set the delay at 30 seconds. We can confirm this here as well. That should be in 30 seconds. It should allow me to execute this transaction. So right now, I can again go here, look at the proposals. This is being scheduled, and it doesn't allow me to execute. So now we can see that we should be able to see the execute button in a couple seconds. And you'll see the state ready to execute, and the button appears. So now I have this random account that is not a proposer, it's not an owner of any contracts, or I haven't done anything with this account. It's just to show that because I have selected that anyone can execute, that quite anyone can execute. So there we go, and the execution worked. This is currently executing. That is done. And if we go to the token contract now, we can see that the total supply has increased by 1,000. So that is pretty much how time locks are set up, and the appropriate roles are defined. So just head back to the presentation. So there are a couple of risks with time locks. So I've spoken about the time lock contract roles, which need to be set up properly. So it is crucial for there to be at least one executor and one proposer to prevent that time lock contract from being locked out. Also, a contract controlled by a single proposer has all the power over the time lock and can then submit whichever transaction they like. So can be quite dangerous, but also makes it very crucial for there to be multiple community trusted proposers. Also, time lock doesn't stop transactions from being confirmed. It simply broadcasts the action prior to its execution. So any malicious proposals, if not carefully monitored by the community, can still be executed after the delay. Therefore, it's also important for the delay between the proposal and its execution to be long enough for users to react. So for example, PancakeSwap was 6 hours, but a typical delay would be anywhere between 1 and 3 days. Apart from that, there have been cases where time locks were bypassed, but for more in-depth look on how that happened in the past, we have written this blog post about 2 years ago. So definitely take a look at the link in the slide if you're interested. So yeah, that's pretty much it. So thank you everyone for listening. Before we jump into the Q&A session, I would like to tell you that we are currently hiring. So we're looking for blockchain security engineers, full stack Ethereum developers, site reliability engineers, and open source developers. So do make sure you check out the OpenZeppelin website or go to zeppl.in/join for any more information about what we do, how we work, and our core values. Yeah, I'll leave this part for any questions.